Welcome, ladies and gentlemen, boys and girls. Today we are going to solve one of the coolest problem, which is lowest common ancestor of a binary search tree. So this is one of the coolest and easy problems. So we are going to do this. Let me just open my open board over here. So first of all, let me explain you what the problem is saying. So the problem is quite simple. It's not too difficult to deal with it. The question is like we given a binary search tree and we have to find the lowest common ancestor of the given node in BST. Okay. So what it means? What is the lower common ancestor mean? What the LCM means? The LCM means let us talk about this example over here. So the LCM will be 6. I will explain you how. Wait. According to the definition of LCM on Wikipedia, the lowest common ancestor is defined between two nodes P and Q. Lowest node in T has the path of P and Q. Okay, so what it's saying, like it is defined as something like, let's say this body has the path of this one and of this one. You get my point? I hope so. And similarly, like where we allow a node to be descent of itself, so that node has to be descent, in the decreasing one. Okay, so I hope so it will, you get some idea. If still not, don't worry, let's just talk about this one over here. Okay, so this, let's just take this example. So what are we saying? Like we are given P2 and Q8. My mistake, I just did it. Okay, so what is saying, like we are given P equals to 2 and Q equals to 8. Okay, so 2 and 8, what is the LCM will be 6. How? Because it is connected to 2 and 8 by itself. So now you will ask, like, how we gonna build a logic for this problem? The first thing come over here. So to build the logic, let's say you I hope you know this condition. Like in a binary tree, the left side has lowest value from its ancestor, from the main root, the main guy. From this guy, this side has left side has lowest value. Okay, and the right side, this right side always has its greatest value. Okay, from this ancestor, from this root one. If you look at over here on the this LC 6, we have 8 over here, the more than 6, and over here 2, which is less than 6. Okay, so kind of like that. And similarly in this 2 we have 4, which is greater than 2, and 0, which is less than 2 on the left. I hope so you get the idea. Okay guys, so let us now start coding this problem. This problem is very simple. It's not too hard, and I really appreciate this problem. So let's just see how we're gonna do this. So wait a second. Okay, here we go. Let me just remove this thing over here from myself for you guys. Okay. Yeah, all right, here we go, ladies and gentlemen. So what I will do, first of all, I will say, if my p value is less than my root value, if my p value is less than my root value, then what does this thing mean? This thing means the value, it might be present on the left. If the value is less than, then we are talking on the left side, obviously. And the q value is also less than the root value, then it means like we are talking about its left side. We are talking about its left side. Simple. So how we gonna traverse? So I will just simply call this lowest common ancestor, the function, and this function help us to traverse over there and give us root dot left of p of q as well. Okay guys, so and I have to return this as well. If you remember, I have to return this as well. Else if, what the next condition will be? The next condition will be the p value is greater and the q value is greater than the root value. If that's the condition, then what does this mean? It means the values are presenting on the right side of the tree. Okay, on the right side. Simple. I think this discussion is very simple. I hope so you get idea what I'm saying. So anyways, if you still have any doubt, I will suggest you to let me know in the comment section. I will definitely gonna list to you guys. Okay, here we go. Alright, so now what I will do, I will simply return what same thing, lowest common ancestor, ANCES okay guys, root dot right of p and q. Okay, else what if there's nothing, then we simply return root. Else return root. If let's say it does not have any leaf present, the root doesn't have any leaf, so it's completed. That's all the code is, ladies and gentlemen. Let me just give a quick run hit to this code so that you can see. And here we go, ladies and gentlemen. So it's accepting very well. Okay, let me just submit it and I will give you its time complexity and space complexity. And here we go, ladies and gentlemen. So it's accepting very well. So guys, this code is accepting very well. So I just want to say the time complexity in this one, we are dealing with big O of n, and the space complexity is big O of 1. Why big O of 1? Because in the iterative one, So because we are using iteration over here, not recursive, so that's why. And time complexity because like we might be deal with because we are talking about the worst case. So in the worst case, it is big of n. Okay, so ladies and gentlemen, I hope this things here, or should I write it over here as well for you guys? So if you don't mind, our time complexity is big of n, and space complexity is big of 1. Alright, so I hope so this thing is clear, and thank you very much, ladies and gentlemen, for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys. Believe me, I love you. Take care, bye bye.